Hello guys, welcome you everyone. I am Digvijay Gore. Today I am with an interesting topic of discrete mathematics. In this session, we will discuss about canonical product of sum, which comes under the discrete mathematics topic. So today our main agenda will be canonical product of sum. But canonical product, there are two types of canonical forms. One is canonical product of sum and another is sum of product. But today we focus only on the canonical product of sum. Before starting this session, let's know something about this canonical product of sum. As you can see, canonical form standard SOP and POS. Now the SOP means sum of product and POS means product of sum, that is we are going to see here. Any boolean function that is expressed as a sum of min terms or as a product of max terms is said to be in its canonical form. This statement I will explain with an example in next slide. Similarly, when the POS form of a Boolean expression is in canonical form, then each of its term is called as max term. One more statement, that canonical POS means product of sum is also named as product of max term. How it is that I will show. This is our and jointly for which output is low or false, and we know that and is also known as injunction sign. So let's move toward our main example of canonical product form. Here is one example of canonical product form in simple. As you can see, there are three variables, namely p, q and r, and they are connected by the plus sign. So it becomes a plus. But we know that plus is also known as disjunction, and these two statements are connected by the product, which is also known as injunction, and this whole statement is known as Boolean form. Let's move toward the today's our main problem statement. Our main problem statement is obtain the product of sum of canonical form of following formula. The following formula. Our statement is P injunction Q injunction R bracket disjunction negation P injunction Q injunction R disjunction negation P injunction Q injunction negation R. So first I find out the what is the truth table of this. I already find out, and the last table last column of this truth table is 1 0 0 1 0 0 0 1. By using truth table we can easily form the POS of canonical, but I will show you at the last of this video. Now we have to find this by mathematical form. So let's toward our main problem statement by mathematical form. Here I am going to give your explanation about this. This is our main problem statement, P injunction Q injunction R. So let's move to the next step. This is our next step. As you can see that we keep the problem first statement as it is, and we apply the Boolean equations on this next two operators, and we see that here we use the distributive law by multiplying this negation P with this bracket negation P injunction Q injunction R, and samely here negation Q multiply with this bracket, and samely here negation R is multiply with this bracket. This law is also known as distributive law. Next step, here we here we keep the first as it is, and we apply the remaining one, and we here we use again the distributive law by multiplying this negation P with separately with again this bracket. As we can see, negation P disjunction negation P Q disjunction negation P injunction R disjunction negation P. Similarly, we do with remaining ones. So let's move next part. Here we solved this small brackets, and the output of this whole statement is come in that in this output. So we can see that again this negation P, we used a distributive law and multiply with this first statement, and here the remaining steps goes cancel. For example, this R and disjunction negation R, this get cancelled, and Q disjunction negation Q also gets cancelled, and we keep remaining terms as it is. So again we multiply here the distributive law, negation P with P, negation P with Q, negation P with R, and we keep the remaining part as it is. So this is our last step, second last step I can say, that here we use the complement law of P disjunction negation P, and the remaining terms will be as it is. And again by using the distributive law, our the last step becomes this, and we can see this is the canonical product of sum. As we can see, there are all the three variables in all statements, and this is our the last output of this problem statement, as we have find out that the canonical product of sum from the sum of product. Thank you for hearing.